So this is what we ended the class with last time, these 5 equations. And we did a few examples on them. Everything went fine. Today we're going to change them to moving up and down. We're going to be talking about free fall. Free fall is when you drop something. Gravity is pulling on it. That's why it falls down. Now, if you put a parachute on that, that's not a free fall. If you tie a string to it, lower it slowly, that's not a free fall. A free fall means there is no other forces pushing upward on it. Again, wind or air resistance is a force that's pushing upward on it, but we're going to neglect that for the purpose of this class. So we're going to say neglect air resistance. So if that's the case, we do have free fall. So when you have a free fall, we know one thing, that the acceleration here, we call it actually g instead of a, because it's gravity, and it is 9.8 meters per second squared. And it depends if you decide to use up as positive or down as positive, so it might be negative or positive. Let's see what our book does. So I'll stay with the book, but it really doesn't matter. You decide. You'll see me mix and match. You'll see me in some example, I use up as positive, down as negative. And the next example, I use down as positive, up as negative. I just want to see what our book does. Where's gravity here? I can't tell yet quickly. I don't see enough any examples to see if G here they use positive or negative. I think we'll use up as positive for now and down as negative. So if I use that, then gravity is negative 9.8. So these equations that you see here, I can change them now when we're talking about free fall to V equals V0. This will be plus negative 9.8 times T, because gravity is negative 9.8. Or I can say G times T. This equation here doesn't really change. There is no acceleration in it. It stays the same. But this equation here, instead of x, well, this one might change. Instead of x, we might call it y, because you're going up and down. It's y sub 0 plus 1/2 v plus v0t. This one, I'll change it to y equals y sub 0 plus v0t plus 1/2 times negative 9.8 t squared. And this one here will be v squared equals v0 squared plus 2 times negative 9.8 times y minus y sub 0. The one under it becomes v squared equals v0 squared plus 2 times negative 9.8 times delta y, because you're moving in the y direction, not in the x direction. So I'm only changing x really to y for these equations. That's all I did. And I changed the acceleration to gravity, which is negative 9.8. So I could have wrote g instead of negative 9.8, because that's what g is equal to. Everything else is the same. So let's take an example of free fall here. Let's say we have a diving board. There's my diving board. And usually these diving boards, let's see, how high above the water are they? We'll say like a good sized pool here. 3 meters. So there's the water here, the pool, and there's the diving board. It's 3 meters above the water. Let's say a person steps. I use the word steps instead of jumping. Steps off the end of the diving board. I use the word steps off for a reason. What do you think my reason for that is?
So you don't have to account for going up?
Exactly. There is no initial velocity in the y direction. You didn't jump up or down. You didn't throw something down or jump up. That tells me my initial velocity in the y direction is 0. I'm talking about the y direction, up and down. You didn't jump up. Somebody didn't throw you down here. So that means my initial velocity in the y direction is actually 0. The question is, how long, time-wise, would it take the person to hit the ground? So here's the first question. A, how long does it take the person to reach the water? I don't know. That's the first question. How long? Time-wise. And maybe part B, what is the person's speed? On entering the water. They said speed. They don't care about the direction. We know it's coming down. So let's list what we know. We know the initial speed was 0. What else do we know? Again, I'm using up as positive, down is negative for this problem. I'll mix and match just to show it doesn't really make any difference.
Negative 9.8.
We know the acceleration gravity, or acceleration, is negative 9.8 meter per second squared. What else we know?
The height.
Okay, the height. That becomes important. What are you going to measure the height from? Are you going to use the diving board as reference or the water as reference? Doesn't make a difference. You pick one of them.
The water.
Do you want to use the water as reference? Okay. If the water is reference, we know what the initial height is. What was the initial height?
3 meters.
Plus or minus?
Plus.
Above that, that's a plus. Correct. We know what the final height is. Because for part A, we're talking about when you reach the water. So when you reach the water, what's your final height? 0. Notice if I use the diving board as reference, then my initial height becomes what?
3 meters.
Nope, the initial height. If I use the diving board as reference, 0. And your final height will be what? Negative 3. Very good. So this is what we have. Do we have an equation that puts all these pieces together?
Number 4.
Number 4, y equals y sub 0. Okay. Y equals y sub 0 plus v0t plus 1/2 gt squared. Y, which is 0, equals 3 plus 0 times anything is 0 plus 1/2 times negative 9.8 t squared. 0 equals 3 minus 4.9 t squared. 4.9 t squared equals what? 3. T squared will have to be 3 divided by 4.9. Which is 0.612. T is going to be the square root of that number, which is 0.782 second. So it's going to take roughly 0.8 second. So if you want to use one significant digit, 0.8 second for the diver to reach that water. The next question is, what's the person's speed? How fast was he going when he hit the water? So again, let's list what we know. We know the time if we need it. So we know the initial speed again is 0. We know gravity, which is negative 9.8. We know the initial height, which is 3. We know the final height, which is 0. And we're looking for the final velocity. I can use the last equation, equation 5 probably. Two times gravity is negative 9.8. Y minus y sub 0, y is 0, y sub 0 is 3. Notice that number is positive now. $58.8. And V will be plus or minus. Mathematically, there are two answers. The square root of that, which is 7.67. Since we're using up as positive, down is negative, so what's my velocity here? I said velocity, not speed, because velocity is a vector. It has magnitude and directions. Since the person is coming down, so my velocity in this case will be what? Negative 7.67 meters per second. The question is, what was his speed? What is the person's speed on entering the water? The speed. So the speed does not have a plus or a minus, not a vector. We're looking for the magnitude of that number, the absolute value of that number. What's the absolute value of negative 7.67? 7.67 meters per second. So be careful if the question says speed versus velocity. Velocity, you're going to write negative 7.67. Speed, you're going to write 7.67, not a negative. Okay. Any question on this one? Let's try another one. let's say we have, what should we use? A volcano? Okay. A volcano erupts and lava is going up in the air. So here's the lava. There's the volcano. And lava, it's red fiery color. It's going up in the air, shoots straight up in the air, and it comes back. And I can't really get close to the lava. It's too hot to calculate the initial speed. So I'm far away watching that. And I have a stopwatch, or I have my iPhone with me, so I set it on stopwatch, and I timed the lava from the time it went up to the time it came back. And let's say the time it took for it to go up and back was, I don't know, let's use 4.75 seconds. And we're neglecting the wind resistance, which means once the lava leaves that mountain, there's nothing acting on it except gravity. That's it. That's the only thing acting on it, gravity. So what is the initial speed? What is the initial speed? Of the lava. So when the lava takes off, right there, what was the initial speed? That's what we're looking for, initially, when it left that mountain. And you know what? Let me just have fun with it. Part B, what is the maximum height? How high did it go? What's the maximum height? That's the only thing we know about the problem. Somebody has a stopwatch or a cell phone, iPhone, whatever, any phone there with a stopwatch on it, boom. The minute they saw the lava take off, hit the start. When it came back, hit the stop. We know the time was 4.75 seconds. That's all we know. And I'm asking now to tell me how high did it go? And after that, tell me also what was the initial speed of that? Let's look at part A. This is part B here. Maybe I can squeeze them on one page. Let's write what we know for part A. We know the time to go and come back is what? 4.75 seconds. I'm looking for what? The initial speed. What else do we know? There's other stuff that we know wasn't given to us. What do we know? Acceleration, gravity. Negative 9.8. What else do we know? Okay. Let's use this as reference here. The edge of that mountain there. What was the initial height of the lava when it left? 0. What was the final height when it came back? 0. Because it went and it came back. Is there an equation that we can use that has all these pieces in it? Could I use y equals y sub 0 plus v0t plus 1/2 g times t squared? This is 0, 0. V0 is unknown. I'm looking for it. We know the time is what? 4.75 plus 1/2 negative 9.8 times 4.75 squared. .75 V0. This will be a minus. If I push the right button, that's 110.56. Move the 110.56 to the other side, becomes a positive. And what's the initial speed? Divide the 110 by 4.75. Initial speed was 23.275 meters per second. In case you're curious about how fast, that's approximately 51 miles per hour speed. You multiply it, convert that, you multiply it by 2.24. Actually, I left the 4 out. 23.275 times 2.24, 52, not 51. Approximately 52 miles per hour. So it has a good speed. It wasn't like just a little poof. That thing went up in the air. Actually, part B will tell us how high it's going to go. Let's look at part B. Let's talk about, this is the maximum height right here. This is the maximum height. Let's call this distance h. We're looking for it. How high did it go? Well, the time to go from here to there is going to be what? To the top. Not all the way back, to the top.
2.25.
Half of that number. Correct. So take 4.75 divided by 2, which is 2.375 seconds. I know the initial velocity now is this number, if I want to use it. 23.275. I know the initial height is 0. I know the final height is h. That's what I'm looking for, the height, h. I know the acceleration, which is gravity, and that's negative 9.8 meters per second squared. And do we have an equation that will put them together? Probably the same one. I can use the same one I used. Y, which is the height, equals 0, plus V0, which is, we said, 23.275, times the time, which is 2.375. This will be a negative when you plug in these numbers, 4.9 times 2.375 squared. A half times 9.8 is 4.9. .275 times 2.375 is 55.3. Take away from it 4.9 times 2.375 squared. 27.6. 55.3 minus 27.6. We're talking about roughly 27.7 meters. About 90 feet high, approximately. 90 feet up in the air. That's approximately. Let's take another example. Okay, you are sitting or standing in top of a building here. We'll use this building. This is a 6-story building. Let's say the height of that is what, 50 meters? Here's you. In your hand, you have a water balloon here. Big water balloon. You see your physics teacher walking out of the building, and you're not happy with the test you just had. So you try to hit them. You fire that water balloon straight down at him with initial speed, straight down, of 5 meters per second. I'm going to assume the distance from the water balloon to the head of the teacher is the 50 meters. You know? So let's assume the distance from here to there is the 50 meters. Otherwise, you're going to find out how tall the person, how tall you are, where was the water. When you hold the water balloon, your hand above your head, and you throw it down, probably that balloon was above that building by the same height as you are. Because you're standing on top of the building like this, the teacher. So you got to look into how high was the teacher. So what's that distance from the water balloon to the head? We'll assume that's 50. So again, how fast, what was the speed of the water balloon when it hits your teacher? Again, it doesn't look like we gave you a lot of information, but we did actually. If we use the teacher as reference here, his height, his head, if I use that as reference, then I know the initial velocity is what? Try again. Almost. -5. Remember, we're using up is positive, down is negative. What else we know? What was the initial height of the water balloon? 50 meters, good. What was the final height when it hits the teacher's head? 0 meters. What is the acceleration? Yep. And we're looking for what? The final height. Final velocity, not the height. Maybe I can use v squared equals v0 squared, I heard somebody say that, plus 2 times g times y minus y sub prime. I mean y sub 0. We're looking for that. V0, which is what? -5. You're going to square it, plus 2 times -9.8. Y, which is 0, minus 50. This is 25. This will be a plus 980. 1,005, I think. And again, mathematically, V will be positive and negative. Two answers. The square root, what is it? The square root, oh, clear, of 1,005, which is 31.7 meters per second. But since the balloon is coming down, what is your velocity? Negative 31.7 meters per second. Which is approximately 71 miles per hour. So if that water balloon is heavy, it will do some damage to that person. It's heavy just like a baseball. You're getting hit by a baseball. I know the water balloon is going to pop probably, but still, when it hits you, probably have some whiplash there. Crushes your neck a little bit there. 71 miles per hour. The only time it could be tricky if I do this kind of a problem. You're in a hot air balloon. That's a hot air balloon. And you are here. And the hot air balloon happens to be rising. That's the balloon. The balloon is rising at the rate of speed of 3 meters per second. And you throw, from the hot air balloon, you throw down with initial speed of 5 meters per second your hat. So I don't need my hat. You throw it down to somebody down here. Let's say the initial height of the balloon was, I don't know, 20 meters. Hat definitely will feel the wind resistance, but we're going to neglect that. So neglect the wind resistance. If you neglect that, that's definitely free fall. So we're neglecting the wind resistance there. So what do we know then? What are we asking for? How long was the hat in the air before it hit the ground? How long? Let's write what we know. What is your initial speed? Again, up is positive, down is negative. Try again. I heard -5. -2. Why -2? Sure. You're in that balloon, right? You're holding that ball. That ball is moving at 3 meters per second upward. Then you throw it down. The difference between them is going to be -2 meters per second. When you're sitting in a car and you're driving, let's say your mom is driving you to school, going on the highway at 50 or 60 miles per hour, You look at your mom, you look like you're not moving. But to somebody on the side of the road, how fast are you moving? 60 miles per hour. You move in the same speed as the car. That balloon was moving upward the same speed as the hot air balloon. 3 meters per, or the hat, 3 meters per second. Now you throw it down with 5, 3 up, 5 down, the net result is 2 down. So your initial speed is actually negative 2 meters per second. If I use the ground as reference, my initial height is what? 20. My final height is 0. I'm looking for the time, and I know the acceleration. So that's all the pieces. Now, any equation that has them? I could use y equals y sub 0 plus v0t plus 1/2 gt squared. Y is what? 0. Y sub 0 is 20. V0, which is negative 2, times t. This will be negative 4.9, that's t squared. I'm not really a fan of negative t squared, but I'll leave it there. I have negative 4.9 t squared minus 2t, I like to put them in descending power, plus 20. I can multiply everything by negative 1. I don't like the negative here. 4.9 t squared plus 2t minus the 20. What kind of equations do we have? Isn't that a quadratic equation? You can solve a quadratic equation if you know your A, B, and C. A is 4.9, the coefficient of t squared. B is the coefficient of t, which is 2. And C is the constant, which is negative 20. How do we solve that? Let me just write what I know here. Instead of having that sheet of paper, A equals 4.9, B equals 2, C equals negative 20. We can use the quadratic formula, which is what? Let me just write it down in red. We're solving for the time. Minus B plus or minus the square root of b squared minus 4ac divided by what? 2a. Plug in what we know. Negative 2 plus or minus 2 squared is 4 minus 4 times 4.9 times a negative 20 divided by 2 times 4.9. This is 396. Take the square root of 396. Which is 19.9 roughly, divided by 9.8. We have two solutions. Minus 2 plus 19.9 divided by 9.8, and the other one minus 2 minus 19.9 divided by 9.8. This one is 1.83 seconds, and negative 2 minus 19.9 divided by 9.8. This is negative 2.23 second. This answer is trash. Why? Negative. Time will never be negative. We're doing how long was the hat in the air. We're looking for the time. So the only correct answer is the 1.83 seconds.